There we go. Like I mentioned in my announcement, my wife and I welcomed a baby a couple weeks ago. He's almost 3 weeks old now. His name is Hank, and we're all very excited about him. And let me share. I'll just hold up a picture. Let me see. What's a good picture? Nope, 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 nope. Oh, here's one. This is me sleeping. Wait, no, I'm not sleeping. I'm awake there. Hank's asleep. So he's doing really well. We're all very excited about that. Um, so thank you guys very much. I really appreciate it. It's very wonderful. Um, so, um, let's see. We just finished spring break. We had a week before then that stuff was asynchronous and remote. With those Ed Puzzle tools. I got a couple of emails about Ed Puzzle, and some people were getting a prompt that it said that it was incomplete, but they had actually completed it. Um, and what for a couple of those folks, I looked into it from my end, and from my end, I saw that um, um, I just got to okay, so I'll just send a private message. Um, So from my end, I saw a couple of folks that they got a notification that their work was incomplete, but from what I saw, it said that they were also incomplete, but they had like a perfect score on things. So basically what I'm getting at is if you did the questions, even if it registers as incomplete, I'm going to kind of transfer that as you completed the work. And I will update those grades probably tomorrow or so. Um, so I would not really stress about that at all. Um, with that in mind, um, we have an exam on Wednesday. So today, and actually, let me go ahead and I'm going to go ahead and switch over to the PowerPoint. This is going to be kind of our exam review. Oh, rats. Move that cord. Sorry about that, everyone. Um, this is going to be our opportunity to review for this exam. And I wanted to let you know that I made some changes to the exam, kind of the format that we're going to be using. Nothing radical. I mean, we're still sticking with it's going to be conducted remotely, obviously. And in addition to that, it's still going to be through Proctorio. However, the one thing that I'm going to make as a change, because I feel like it didn't really accomplish what I was going for, and it really just kind of was I think, an inconvenience and a nuisance for everyone, was the logging into Zoom as well. Um, I think that just caused a lot more of a headache and stress than I really wanted. Um, Now, with that in mind, I wanted to go ahead and give you kind of an update of like, how does that matter? What's the significance of that? So I'm going to go ahead and go full screen. Then I'm going to share that screen. And here we go. So here's a couple of details. Your practice exam is up. So I'm going to go ahead and get the pen. Practice exam is up. That practice exam is very similar to the actual exam in the sense that it also has 40 questions. just like your actual exam will. So 40 questions. And the breakdown of that is 10 questions are, I'm just going to label it as, no, I'm not going to label it as E. I'm going to say module one stuff. 30 questions are module two, or the most recent stuff. Um, and so the point of this and the benefit to you guys is this is an opportunity. If you didn't do quite as well on your first exam as you had hoped, well, this exam is going to be able to replace that exam score. Um, and I think that after the grades are posted and everything, you'll see how that kind of splits up and how that works out, how that impacts your grade. Um, so the actual exam, actually, I'm going to go to a whole new slide. So I'm going to say exam two. 40 questions. How about 40, not four? I'm going to label it 10 old stuff or module one and 30 your new stuff. And that new stuff is what I'm going to focus on today. If you're curious, like, hey, how could I study the old stuff? Look at old quizzes. And a really good resource is going to be exam one. Look over those questions. Were there questions that you're like, oh man, I was split between these two and I flipped a coin and I picked the wrong one? Or was it like, I have a fundamental misunderstanding of this. And I still do. Um, now, with that said, the new stuff, that's what I'm going to be focusing on today. And I'm going to focus on that in just a little while. But I wanted to kind of give you some parameters of what to expect for this exam. Is the exam one practice exam open to use as a resource? I believe that it's still open because I think that I've got that set up to be open through the end of the semester. If you give me a second, I can check and confirm that. And that is a good resource also. Let's see. Quizzes and practice exam number one that has 41 questions. The answers are available as of February 5th, but it's still open. Yes, the exam number one practice exam is open, so you can look through that. Great question. Um, can we use our exam? Okay, exam number two. I'm happy that you asked that, Lindsay. Um, it's going to be a new note card, so you'll have to use a new note card for exam two. So now same size, same 3 by 5. Um, so what I would do is I would look back at my exam one note card and, try to look at that information and be like, is there something that was on here that I didn't need? Is there something that was on here that, you know, I had a full understanding of, but I put it on there as a safety net and I didn't really need it? Um, and then whenever you're thinking about your exam one or the old stuff, I would say, there's only 10 questions. So we could probably come up with a pretty quick list of really important topics. Chemical and physical changes and properties. That would be something that would be like a high value item. So I'm just trying to come up with like, if I was going to write 10 questions, how would I do that? Or what kind of material would I look at? I'd look at scientific notation. You know, can you take a number written in scientific notation and convert it to full notation? Um, Density, then scientific laws, like the law of conservation of mass, definite proportions. Then we've got moles and molar mass. Then model of an atom. I bring up these are like, I'm looking back at the schedule from our first exam, and we had a total of, let's see, that would be roughly 7 class meetings where we had new content. I mean, you could argue that there were 6. But anyway, 6 or 7 class meetings where we introduced new content. These are 6 topics. Now, I bring this up because whenever I'm writing your old exam material or these 10 questions, um, there's 6 topics that I can pull from. Go ahead and add to the chat if you think that I'm going to write 10 questions about a model of an atom. I know I kind of gave you a silly prompt there, but I'm not going to write 10 questions that are just about the model of an atom. So what you should expect is one question about chemical and physical properties, one question about scientific notation, one about density, scientific laws, moles and molar mass, model of an atom. I got a question about can I go over the system to drop exam grades? What I'm going to do is I'm going to cover the exam 2 content, kind of give you a little bit of a review. And then once I'm done with that, I'll come back to talk about kind of the exams and grades and everything like that. So if you want to hang around for that, I'll hold that till the end. But with that said, it's not going to be like at, 10:50 we'll begin doing that discussion. Okay, so that's kind of a rough idea. And then whenever you look at those things, look at these different prompts, I'm looking at a couple of these and I'm like, okay, well, chemical and physical properties. I think it's worthwhile to ask a question about a chemical property or a chemical change and a physical property and a physical change. So that's where I'm going to get 2 questions from. Scientific notation. Well, that can be a question where I write out 3.4 times 10 to the negative 6. Convert it. Okay, well, if I were to convert that, what I would do is I'd move my decimal place 1, 2, 3, 4, 5, 6. There's my decimal 0.0000034. This is equal to 3.4 times 10 to the negative 6. Okay, so I mean, really, that's a topic where I'm probably going to get 1 question. Density. Hmm. Density, that's a question where I could write it in a couple of different ways, but really I'm probably going to only have 1 density question. And what I mean by that is, um, I would say something like an object has a mass of 13.2 grams and it occupies 347 milliliters. Do you think that you could calculate the density on that? I think you could. I think I could too, especially as I pull up my calculator. I would say, well, my mass, 13.2 divided by 347. And I would get a density of grams per milliliter of 0.038. Now, there's a couple of different ways that I could ask a density related question. Um, but chances are I'm only going to have one density question. Okay, so now what I'm looking at is I got 7 questions put together from the old stuff. Scientific laws, I mean, that to me is kind of a, I could maybe pull 2 questions out of there. No, I mean, sorry, this isn't to flex or anything, but I could definitely get 2 questions out of that. Yeah, yeah. But is it really worth a lot of time? I mean, the scientific laws are important, but understanding what they are and knowing the terminology is a little bit like trivia almost. So that's probably not where I'm going to get an additional question. Let's see, again, I've got 7 questions, so I've got to get 8, 9, and 10. When I'm looking at these last two, moles and molar mass, honestly, that's probably where I'm going to get additional questions. I could, I always like to think about scenarios, different scenarios. If I wrote 100 different forms of this test, I might have one where I've got 3 questions about moles and molar mass and 2 about the model of an atom. So that gives us, let's see, that would be 4, 5, that would be 10. Then, on a different day, I might write it where I have 2 and 3. And the reason for that is those last 2 items are really important for understanding chemistry. Um, Physical and chemical properties and physical and chemical changes are important, but that's kind of like that's really like low-hanging fruit. Um, so what I would do if I were you is I would make sure that, and I'm going to clear all this out, and um, I always like to think about this as a kind of a urgency. Like, what's the most urgent thing that you focus on? Like, if you had 1 hour, if you were going to spend 1 hour studying the exam one stuff, would it make a lot of sense? And let's say that this is the profile, this is the number of questions. I'm going to say number of questions. Um, would it make a lot of sense for you to spend 55 minutes focusing on these 3 topics and then take your other 5 minutes and focus on and this is if you only had 1 hour. Um, if you think that would make no sense at all, go ahead and add to the chat. 55 minutes where you're spending it on these 3 topics where there's 3 potential questions, and then 5 additional minutes, the last of that 1 hour, on chemical and physical properties. If you think that's a bad idea, okay, right. So if you did that, then you totally neglect these things. Now, what I would recommend is instead, I would say, okay, well, if you've got 1 hour, what I'm going to do is I'm going to say, all right, he's given us this idea that we've got 10 questions. Half of those questions come from these 2 things. So, even if that's something that I felt pretty good about, I would still spend almost at least half of my time on this, just because then I can kind of shore up my knowledge. Now, with that in mind, and then, I distribute the other half among the other topics. But when you're thinking about that, when you're considering that, then I would kind of suggest that you look at this and say, okay, moles and molar mass. Um, what do those questions look like? Well, one of them might be, and sorry, let me rephrase that. What are those questions going to be? Well, those questions are probably going to be coming from the periodic table. So I'd familiarize myself with the periodic table and make sure that I know what an atomic mass is so that I can answer questions related to that. Then for model of an atom, well, what are we talking about when we talk about this, the model of an atom? There's a couple of different things. First and foremost are, and I'm going to label it as SA, are subatomic particles. We've got protons and neutrons, and what's our last subatomic particle? Protons, neutrons, and electrons. Absolutely. So identifying those might be a question. Then, when we talk about subatomic particles, we got to think about their charges. What are the charges of the different subatomic particles? Neutrons are neutral, protons are positive, electrons are negative. So, this is all kind of like a strategy on how to approach the old stuff. Um, I always like to break things down into time blocks and say, okay, I have an hour to do this. Or if I'm going to dedicate, whatever the time frame is, I like to kind of adjust it and say, I'm going to spend half my time doing this and go in with like an intentionality and a plan because, if you do that, then you have at least you can understand what your strategy was. So then whenever you're taking the exam and, okay, well, I spent half my time looking at scientific notation and there was one question. Ooh, that's one out of 40 questions. That was worth 2.5 points. Ooh, that wasn't such a great idea. Okay. Um, so that's my suggestion for the old stuff. Now I'm going to go on to talk about the more recent stuff. And in order to do that, um, I want to use some models. So when it comes to the more recent stuff, a lot of it stems from drawing. Now, you might think, oh, great. How am I going to draw with a time constraint? You're not going to have to draw. Okay. So then how would you be asked a question where your ability to look at or understand a Lewis structure be asked? Well, I think that a good way to approach this is to use a couple of models. And let's go ahead and use one that everyone's familiar with, H2O. Now, H2O, or water as it's commonly known, also has a different name. And that different name follows our nomenclature. So I know that I presented drawing. Now I'm kind of throwing a curveball and saying, all right, well, let's talk about nomenclature. But it's important to understand that nomenclature. Can anyone add to the chat the name for H2O that is not water, but uses our terminology? Haley, absolutely right. Dihydrogen monoxide. Dihydrogen, lo and behold, we have two hydrogens. Monoxide, one oxygen. Okay, so you're absolutely right. So dihydrogen monoxide. Now, with that in mind, there's one question right there. Can you name a compound? Okay, can you name it based on the atoms that are in that molecule and the number of those atoms in the molecule? Okay, now the next thing is to classify. Okay, this classification, there's a couple of different ways that you can classify it. One way is we classify compounds as being ionic, or molecular. And I use this molecular, I'm going to say molecular slash covalent. Okay, now with that to say, whenever I present H2O, for example, and I ask the question, how would you classify this? You'll have answer option A, ionic. B is molecular slash covalent. C would be, I don't know, I always like to think of some silly uh, scientific sounding names. And because I have a 2x2 Rubik's Cube on my desk, I'm going to say your third option would be like Rubixular. And that's really going to be a tempting option because you'll be like, Rubixular. And I know I'm speaking from my own experience. If I was taking the exam and I saw Rubixular, I'd be like, excuse my language, I'd be like, oh crap. I must have fallen asleep. I missed that. So I think that it's rubicular. And that would be my answer. It's not rubicular. Rubicular is a fake word that I just came up with. So anyway, your classification would be, is it ionic or is it a molecular slash covalent compound? And in order to answer that question, you have to be able to identify the atoms and classify them. Well, H2O, hydrogen and oxygen, those are both nonmetals. So you would say, okay, well, since they're both nonmetals, this would be a molecular or ionic compound. Okay. A third question from this would be, well, classify H, or let's go with oxygen. Classify oxygen. Is it a metal? Is it a nonmetal? Is it a spheroid? Again, fake word. Or is it a metalloid? So you would have the question where you're classifying the compound and you're classifying the individual atoms. Okay. What I'm doing here is just kind of taking one molecule and basically presenting you with here's a bunch of questions that you could ask or could expect to see based on this one molecule. So I want you to use this as, okay, could I write my own test? Will you be using molecular and covalent interchangeably? That's a great question. And my plan is to use molecular slash covalent every time. Um, so my intention is to use molecular slash covalent every time. And I'm just saying intention just because that's what my plan is, and I hope that I do not overlook that and make any sort of mistakes there. So classify the compound or the molecule and classify the atom or atoms. Okay, so these are three questions from a single molecule. A fourth question could be about electronegativity. Now, electronegativity is a trend, and electronegativity has a scale of basically 0 to 4. Does anyone remember what is the most electronegative element on the periodic table? If you do, add it to the chat. Fluorine, F, you're absolutely right. So that is our most electronegative element. So a question that I might ask would be something like, well, between hydrogen and oxygen, which is the most electronegative? Now, does anyone remember kind of the general trend for identifying a more electronegative element or the most electronegative elements? If fluorine is the most electronegative element, what does that mean for things that are around fluorine? It means they're also a little bit electronegative. Lazaro, you're absolutely right. Oxygen is more electronegative than hydrogen. So you want to look for basically whichever element is farther to the right and up, with fluorine being the highest. Okay, so this is just a set of four questions that I could come up with from one molecule. Name it. Can you classify that compound? Can you classify the atoms? Can you identify which is the most electronegative element? Then we haven't even gotten to drawing this molecule or visualizing the structure. Next would be something like, well, which is the central atom? Add to the chat if you know this, which is the central atom. But typically, when it comes to your central atom and identifying your central atom, you're absolutely right, it's oxygen in this case, but you want to look for the atom that's listed first. Well, in this case, we're kind of looking at an exception to the rule. So we are looking for the thing that is typically written first, and it's going to be, if you have three atoms, the The atom where there's only one of them is going to be your central atom. So oxygen would be your central atom in this case. If you were to take something like CO2, well, carbon would be your central atom. So identifying your central atom would be a good question. Now, Lisa, you're absolutely right. The least electronegative element is going to be your central atom. And I was a little bit, I didn't want to ignore your comment because you are right. No, you're right. But hydrogen is always kind of an outlier. Hydrogen plays these weird games. So that's one of the things that you just have to be cautious of with hydrogen. So it's less electronegative than oxygen, but oxygen is still your central atom. So you're right, but just keep in mind, hydrogen's finicky, I'll say. Okay, so our sixth question would be, well, number of, and we've seen this before, valence. Number of valence electrons. And I'm going to say for oxygen. So I could ask for the number of valence electrons for a given atom. Then I could also ask this sort of follow-up question, the total number of valence electrons for the molecule. For molecule. And if you have a periodic table available or can kind of quickly pull one up, could anyone add to the chat the answer that I'm looking for number 6? Your total or your number of valence electrons for oxygen. And I'm going to use this as kind of my way of drawing out my molecule. I've already determined that oxygen is my central atom. How many valence electrons does oxygen roll in with? 6. You're absolutely right. So question number 6, the answer would be 6. Now for question number 7, what is the total number of valence electrons for the molecule? If you have the answer for that, awesome, add it, but I want to go ahead and add a little bit of a qualifier. This is the total number of valence electrons, total number of valence electrons for that molecule. So that means the valence electrons for oxygen, which we've determined is 6, and then the number of valence electrons for each of our 2 hydrogens. So what's our total number of valence electrons for our molecule? 8. You're absolutely right. Okay. So we've got 8 valence electrons to draw, to work with. Now, another question would be, how many double bonds are present? Fair question. This is a question where I'm really getting to, well, can you draw this? Because these 1 through 7, you could kind of think about this as almost like a checklist. Going through and just saying, okay, well, I've classified it, done. I've identified my central atom. You know, picking up at question number 5, my central atom is oxygen, therefore hydrogen and hydrogen. Okay. Okay. So the number of double bonds. All right. So when we look at this right here, that is a single bond. That's also a single bond. One single bond, and this is another sort of question that I could throw out there, would be how many electrons are represented by let's say a triple bond. Okay. Now, before you answer that, I want to give you an example of what that looks like. Nitrogen, nitrogen. Here is the molecule N2. Now, N2 there, each one of these nitrogens is happy because it has a total of 8 electrons around it. So if I circle this right here, that's my triple bond. Each one of those lines is a single bond. Lazar, you're absolutely right. A triple bond represents 6 electrons. Okay. So now, with that in mind, how many electrons are represented by this single bond right here? 2. Perfect. So that's 2 electrons. That's also 2 electrons. So now, my question number 8, how many double bonds are present? And let me, rather than 2x, I'm going to write double. None. Absolutely right. There are no double bonds represented in that molecule. Okay, great job, everyone. Awesome. Okay, so this is, I know that this is maybe deliberate and it might be like, oh man, Dr. Gray, Joel, thank you so much for welcoming us back from spring break by moving very slowly and putting us to sleep. I maybe will appreciate this, but right now it is just putting me to sleep. I apologize for that. I just want to make this as clear as day, like what you can do, among your peers. Like, hey, I'm going to take this one molecule and deconstruct it and come up with a bunch of questions because this is what I'm going to do to write your exam. Okay, so I'm going to keep going on this. And I don't know that I really apologize, but yeah, I kind of apologize for this. Okay, so question number 10 over here on the left-hand side of the screen. How many electrons, number of E, that H needs? Well, in that case, hydrogen. Hydrogen only needs 2 electrons. Does hydrogen in this model that we're looking at right now, does it have the number of electrons that it needs? It does, because it's sharing electrons with oxygen. Okay, now 11. Number of electrons that O needs. Okay, well, our answer for that is going to bring in the octet rule. I'm going to put a box around that. The octet rule, well, it's kind of a rule that ultimate fighting can be related to. You might think, how and why? And my answer to that is, well, what do they fight in the ultimate fighting challenge? That's right, the octagon. So here we go. We have an octet, 8 electrons. How can we, I get a private message. How can we identify how many electrons an atom needs? Great question. What your default should be is 8. There are exceptions. The octet rule, Lisa, you're absolutely right. Atoms gain or lose electrons by sharing. Hydrogen is an exception. Hydrogen is an exception. It only needs 2. By sharing or, wait, no. Atoms get to 8 electrons by sharing or losing electrons. So in this case, so basically everything wants to have 8 electrons, but there are some exceptions. Exception, hydrogen. Hydrogen doesn't want to have 8 electrons around it. It only needs 2. Another exception. So there are some that require less than 8 and some that require more or can accommodate more than 8. Another exception would be something like sulfur can take on more than 8 electrons. Okay, so if I were to show this right here, are all of the atoms in this model that I have drawn, do they all have the number of electrons that they want or need? We already know hydrogens do. Haley, you're absolutely right. No, they don't. So if hydrogens are fine and all of the atoms in this do not, well, then our one problem is our oxygens. So how do we fix that? Everything to the right of phosphorus can take on more than 8 or just S? No, everything beyond that. Everything after phosphorus can take on more than 8 electrons. Does that mean that they absolutely do? They don't always, but they can. That's the big thing there. Okay, so the next question would be basically, how do we fix this model of H2O? Well, we could ask the question, how many LP or lone pairs of electrons does oxygen have? Well, I'm going to put 2 electrons right there. How many lone pairs of electrons is that? And this is an important question. It's a little bit tricky. How many lone pairs of electrons did I just draw? Think about a pair of shoes. I drew one lone pair. Fantastic. Great job. Now, how many lone pairs have I drawn? Absolutely. Okay. So now my next question is, I just drew an arrow towards a bond. Is that a lone pair of electrons? No, it's not. It is not a lone pair. It's a shared pair or a bonded pair. It's a subtle difference, but it's an important difference. So now my next question would kind of be my last question here, 13. Is this structure good to go? Oh, dang it, Joel. No, learn how to draw a box. There we go. Is that structure good to go? Yep. So we took this one molecule, we took water, and we deconstructed it. We came up with 13 questions based on the formula for water alone. This is something that I would encourage you guys to do, and use it kind of as a practice mechanism. Um, I heard somebody was unmuted. I'm not sure if that was intentional or not. Did anyone have a question? Because I couldn't really hear very well. Okay. That's what always happens to me as well. Whenever I forget that I've unmuted myself and then somebody asks like, "Hey, did you have a question?" I'm like, "Nope." I'm the Homer Simpson disappearing into the woods or into the leaves meme in that moment in a Zoom meeting. Okay. So this is the way that we can come up with basically like 13 questions at least. And so if you're kind of thinking about this in terms of our exam, we've got 10 questions right here. So 10 questions from our old stuff. Then we got at least 13 questions from this right here. Are there additional questions that can come from looking at a molecule? Yeah, absolutely. Um, in addition to that, I'm not just going to build an exam on one molecule because if you're good with the structure of CO2, but you don't know the structure of H2O, I'm not going to say, oops, sorry, tough, you rolled snake eyes, not my problem. That's not what I'm going to do. Instead, what I want you to do is think like, okay, well, there might be this many questions about this molecule, Or there might be like six questions from this molecule. Then there might be six questions using a different molecule, and then five questions using a different, and so on. Now, with that in mind, what I wanted to do was just kind of go through a couple of different models and kind of work through coming up with answering these questions. So I'm going to go back and forth between this slide and the next slide and answer all of these questions. Go ahead and add to the chat if you're good to go and good to proceed. Add anything. Thumbs up, why. Yeah. Great. Okay, everyone. So what I'm going to do is I'm going to pick a little bit of a tricky one because I feel like we've got water, but let's escalate it a little bit. Not escalade, but escalate. Let's go higher. It's 1016. Okay, cool. So we've got BRF5. Question number one. Name it. Well, before we do that, I'm going to go 5 questions here. My first question here would be, well, how can I name it? Well, I know that Br is bromine. And then F5. F is fluorine. 5, penta. Now, I did a little bit of a change on the fly there. Fluoride. That IDE suffix is common, or is what you're going to see whenever you're using whenever you're using fluorine in a compound. So bromine pentafluoride. We took bromine Br, 5 fluoride. We use the prefix penta, and we're good to go. Okay, now next up, backwards, classify this. Well, where are these two things on the periodic table? They're both on the far right-hand side. So things that are on the far right-hand side of the periodic table are both known or are going to be known as nonmetals. So this is a pair of nonmetals. This is going to be a molecular or covalent compound. Okay, so 2 questions done. Classify these atoms. Well, again, they're on the far right-hand side of the periodic table. And keep in mind, you're going to get these questions as like a multiple choice question. So you have something to pull from. These would both be nonmetals. And you might be looking at these and thinking these questions are a little bit out of order. They are. It might make more sense for this one to be up here. So, you guys can scroll through and toggle through all the questions that you want. Okay. Electronegativity. Which is our most electronegative element? Is it Br or is it F? Go ahead and add to the chat. Is it Br or F? F. We know that because that's the most electronegative. Now, with that said, you'll have a periodic table. It won't identify which is the most electronegative, but you'll be able to see that based on, where you're looking on the periodic table and everything like that. Okay. Uh, Jumping back. Which is our central atom? Well, our least electronegative element is bromine. Another way to look at it is, well, we've got 5 fluorines and we've got 1 bromine. Lisa, you're absolutely right. It's Br. I think that it's also helpful sometimes to think about, okay, I have a central atom. Let's see. I've got fluorine, electron configuration. Okay. Okay, so I got 2 messages. One was will we get the electron configuration chart on the exam? Are you referencing this right here? Okay, you will not get this. So this will be something that you want to definitely be reviewing. This valence electrons, review this before your exam. Or, this might be something, I mean, it's your call. Um, but this might be the sort of thing that you want to, print up and put on your 3x5 card. Alternatively, I think that, there's some trends. Group 7A, they all have 1, 2, 3, 4, 5, 6, 7 electrons around them. Okay, will we get the electronegativity chart on the exam? If I have a question about the value of electronegativities, I will provide those. So to answer your question of will we get the electronegativity chart with the specific numbers defined? No, but you won't need it in order what I want you to know about electronegativity is the trends. So what I mean is and I have not responded to a private message that I'm just about to respond to. Um, you'll get a question like this, an explicit question not relating to a molecule. Which element is most electronegative? And I'm going to, that would be a question, so I'll end that sentence with a question mark. I'll say A. This is answer option A. That looks like a 4 and Plankton from SpongeBob SquarePants drawn as anyway. There's answer option A. This would be B. Joel. This would be answer C, and this would be answer D. So, does that make sense? Okay, cool. So that's the sort of question that I would be asking where it's like explicit, what's the electronegativity or which is most electronegative? Now, the next question that I got private. Uh, so electronegativity is like which one is further down on the table? Happy that you asked that. Um, if we were to see this question right here with these answer options A, B, C, and D, our correct answer would be this one right here, C, because that is farthest to the right. Some people always say, or some people like to say, up and to the right. That's your trend for electronegativity. You're looking at the periodic table and you're saying, okay, which is most electronegative? Okay, now with that in mind, when we talk about electronegativity, we kind of ignore our noble gases. We use fluorine as the extreme. Now, another question might be, I'll switch it. I'll go like Busta Rhymes and I'm going to flip it on you. Okay. Which element is least electronegative? And again, this would be looking at the trend. Add to the chat your answer A, B, C, or D. Which is least electronegative? A. You're absolutely right. Now, what I want you to kind of be thoughtful of is this is kind of an easy trend to recognize because you can say, okay, well, carbon is farthest from fluorine. I am not going to give you a question like this, which is least electronegative. The reason for that is because if you look at the specific value, you might be like, oh, well, it's actually silicon. Um, but if we're looking for the trends, you might say, okay, well, this is farthest to the left, but this is down. Ooh, or it could be even more complicated if I were to do something like this. Which one is the I'll scribble that out. Which is least electronegative? A, B, C, or D? And then you're like, I don't know. Those are super close. Um, so I will not give this chart on your exam. So this valence electrons chart, I will not give you this on your exam. So this might be a good thing that you put on your index card, or what you could do is come up with some kind of examples and say, okay, well, I am going to draw an example of carbon, nitrogen, oxygen, and fluorine. And those are on the periodic tables, groups 4, 5, 6, and 7. Okay. So now I'm going to go back to where we were. Uh, does anyone have any follow-up questions about that before I go back to where we were? If you do, go ahead and add, send them to me as a private message or just add it to the chat. Okay, so this is 5 questions from this molecule, BRF5. Now, our central atom, we picked that out. That was the bromine. Question number 6. The total number of valence electrons for, let's go with bromine and fluorine. Question number 5. I'm happy that you asked that. Question number 5 is which one is our central atom? And I'll go ahead and kind of give an update here. Central atom. Question number 6 is number of valence electrons for bromine. And then let's see. 7. Number of, go ahead and add valence electrons for F. And then 8. Number of for molecule. Okay. Does anyone have the answer for question number 6? How many valence electrons does bromine have or Br have? 7. Perfect. How about fluorine? F. 7. Perfect. How about for our molecule? It's tough. Well, how many bromines are there? There's 1, so that's 7. Then each fluorine rolls in with 7 valence electrons. And how many fluorines do we have? We've got 5 of them. Yep, 42. We're playing dominoes. We got 42 valence electrons there. 42 total valence electrons. Okay. Number 9, our next question. Let me go ahead and say our next question. We figured out which is our central atom, Br. Then we've got 1, 2, 3, 4, 5. F, 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 F. I'm gonna change my question number 9 here, and I'm gonna write it in. Does or do oh, any atoms in molecule exceed the octet? And I haven't drawn all of the atoms or all of the electrons, but to answer this question, I know that this corresponds to 2 electrons shared. I'm going to go ahead and do this. You got kind of a starfish looking situation, or a sand dollar looking thing there. Each one of those bonds corresponds to 2 electrons. So how many electrons are surrounding bromine? Answer that question. 10. So does bromine exceed the octet? Yeah. So to answer this question, do any atoms in this molecule exceed the octet? Yup. Br. Br does. Okay. I'm going to jump back so I can kind of give myself a reference. Then what I'm going to do is kind of go through, just so I'm going to complete my molecule. So I've got 42 total electrons. Does everyone add to the chat a Y, a emoji, whatever, to indicate, yes, you agree, we have drawn um, all of our atoms and that we have placed a total of 10 electrons. If you don't see those 10 electrons, send me a private message or something like that or whatever. So we've placed 10 electrons in the form of five single bonds. So I'm going to say 42 minus 10. I have a total of 32 electrons left to draw. Now, what I'm going to do is I'm going to go to each and every one of my fluorines. I'm going to put 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2. Okay. So each one of my fluorines has, well, has six electrons in the form of three lone pairs. So I could ask this question. How many LP do each does each fluorine have? Well, the answer to that would be three. Perfect. Okay. Now, another question would be, is this structure, as I've drawn it right now, right? Okay. Emily, Emily, Emily. Well done. You're absolutely right. I've drawn 40 electrons. 2 electrons are left. Now, a fair question there. So, sorry, question number 11, is this right? Not yet. You guys both chimed in with, well, we've got one lone pair of electrons. Now, a fair question is, what do I do whenever I have that lone pair of electrons? And sorry, let me go ahead and minus 30 here. It's 2. When I have one lone pair of electrons, I'm going to throw them on my central atom. So you want to complete the octets of surrounding atoms, and then any excess go to the center, go to your central atom. So now, update. Is this right? Is this structure? Yep, we're good now. Okay. So then I can pick this up and I could say 13. How many double bonds? How many double bonds does anyone see there? I see none. Okay, then 14. How about the number of triple bonds? Ooh. Well, I see, again, none. Then, let's see, what else can I do? 15. Which atoms exceed the octet? All the fluorines are happy as can be. They have exactly 8 electrons around them. Only bromine exceeds the octet. Okay, so what we did here was we basically took one molecule and we broke it down and we cooked up 15 questions from that one molecule. And I bring this up and I want you to use this as basically a tool where you can kind of put together your own exam. Um, okay, just a second. I feel like I don't understand double bonds. If we had 10 remaining electrons, they'd be divided evenly to make double bonds, but I only do that if they're enough to be equal. I remember the comparison to giving kids candy, but I'm not sure if I'm applying the idea right. Um, you know what? I think what I'll do, okay, so that's my jump off from here. What I'm going to do, I got a private message about double bonds. And what I want to do is go ahead and look at CO2, carbon dioxide. And I'm not going to go through all the different steps, but instead, I'm going to jump ahead a little bit and I'm going to say how many valence electrons does, and I'm kind of moving through this a little bit more briskly because this should answer questions about double bonds because this molecule has double bonds. So carbon rolls in with four electrons, four valence electrons. Each oxygen, and there's two of them, they each roll in with a total of six valence electrons. So we've got a total of 12 valence electrons. So if we were to draw this molecule, we'd have a central atom of carbon, and then we'd have a single oxygen, oxygen. That's our bare bones. That's our kind of basic model. Now, at this point in time, how many total valence electrons could I work with? 12 plus 4 is 16. Okay, so 16 electrons minus 4. That's 12 valence electrons. Okay, so I have 12 valence electrons left to draw. Now, go ahead and add to the chat a yes or a no, or yes if you're good for this, if you follow so far. Okay. Some of these numbers pulled them I pulled them from the periodic table, but I didn't show you the periodic table. This is just I remember this. And actually here I can oxygen and carbon. Carbon's got 4, oxygen has 6. Okay, so we've got 16 valence electrons. We've drawn 4, so we're down to 12 left to draw. So 12 is all that we can draw. Now, your process when drawing a molecule is to complete the octet of the outside molecules or outside atoms. What I like to do is I just like to go ahead and say boom, 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 boom. Now, does this oxygen right here have a complete octet? It does. Now, when I go here, does that carbon now have a complete octet? It does. What about this oxygen? Oh, yeah, that's also got a complete octet. This is really exciting because everything has a complete octet. Oh, but there's a problem. How many electrons have I drawn right here? Let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I drew a molecule with 20 valence electrons, but I only had 12 or I only had 16 that I could draw, 16 total. So I've drawn 20, but I didn't have 20 to draw. So is this structure right here? Is this structure right? Nope, it's not. Okay, so it's not because I've drawn 20 electrons. Now what I need to do is I'm going to go ahead and start over. And what I'm going to do is I'm going to complete the octet of my oxygens. Okay, how many electrons have I drawn? 2, 4, 6, 8, 10, 12, 14, 16. Ooh, that's exciting. I'm good. I had 16 electrons that I could draw. Um, so this has 16 electrons. My question for you, is this structure right? It's tempting, but it's not. It is not the correct structure. Would anyone care to add to the chat what the problem with this structure is? Carbon. You're absolutely right. Carbon likes to have 8 electrons around it. Well, oxygen also likes to have 8 electrons around it. So how are we going to appease that? How are we going to work that out? Well, I'll go back to the drawing board. And now what I'm going to do is I'm going to put a double bond in. This double bond represents 4 electrons. Okay. And whenever I do this and I do this, I've got 2 double bonds. Does that carbon happy? It is. It's good. Now I'm going to erase them though, because what I want to do is I want to go ahead and kind of ask the question, well, where are they coming from? If I put 1, 2, 1, 2, that oxygen has 6 electrons that it kind of has through sharing or keeping in lone pairs. Now it's got 8. these two electrons of this second bond, they're shared because each atom says that they have them. So it's kind of like they are genuinely sharing it. They both can claim it, but neither one of them says, "Oh, I have it," and you don't. And there we go. Again. So those that's our structure for CO2. A double bond is basically when you need to draw two electrons, or sorry, when you need to draw four electrons, but you only have two that you can draw. Does that help at all? I'm speaking in general, but for the person who sent me a direct message, does that help at all? Okay, great. So I think that when it comes to drawing a molecule with double bonds, I'd like to go ahead and draw something like this and say, okay, well, that's what I would love to have happen. But does that work? It doesn't. Okay, well then, what's a model that works? Well, this works for part of our atom, but not all of it. Okay, now the last two things that I wanted to talk about before I talk about the exam scoring is polar or non-polar. Whenever it comes to polarity of a molecule, the way that I think about it is I always try to think about it as, is this molecule, does it have something that there's an, uh, let me rephrase that. When you're looking to classify a molecule as polar, look for a couple of things. Not symmetry or no symmetry. That's the first thing. The next thing is, and this is kind of a supporter of that, is lone pairs of electrons. Now, I'm going to jump back. This molecule right here. If we didn't have that lone pair of electrons, that molecule that I have circled, okay, add to the chat if you understand that the molecule, the way I have it drawn right here in this circle, is incorrect. It's incorrect because I don't have all of the electrons drawn. Okay. Now, I'm just using this so I can kind of save time and not have to draw something new. If this were the correct structure, would you classify this as polar or non-polar? And before you answer that question, I want you to think in terms of symmetry. It's always nice to think about like a face being symmetrical. Well, I've got one eye on this side, one eye on this side, half a mouth on this side, half a mouth on this side. Okay. When we want to classify something as non-polar, or if we're looking to classify it, and we see that that molecule is symmetrical, we would classify it as non-polar. Now, in this case, it's kind of tricky. When you read polar, I want you to think about, and this is how I think is helpful, polar. And whenever I say polar, I think about like you're having a game of tug of war. Let's imagine that you have, does anyone know who well, let's just go with let's see. Wrestler John Cena. Let's say that we have cloned John Cena. Let's say we've cloned John Cena, and John Cena represents all of my fluorines. Does anyone, if you don't know who John Cena is, just insert strong person in place of John Cena. Okay? Can we give a yes or whatever that you're good with this? Add to the chat. Okay. So what we've got here is we've got five John Cenas. And they're playing a game of tug of war. Yes, you're absolutely right, Daniel. So we've got these five John Cenas. It's very true. In this case, we can. Thank you very much for indulging me here. Um, which one of those John Cenas is going to win that game of tug of war? None of them, because they are all equally strong. And so basically, their strength is going to cancel one another out. Okay, I got a private message about identifying covalent or ionic, and I'm going to get back to that. Now, each one of these forces, each one of these John Cenas, they're pulling in equal and opposite directions, so they cancel one another out. Now, whenever I put this lone pair of electrons here, my question is, okay, sorry, before without this lone pair of electrons, this would be considered nonpolar because all of those forces are not pulling and winning. Now, when I put this lone pair of electrons here, um, think about this lone pair of electrons as basically being like, um, I don't know, that's kind of all of my wrestler people. So I'll go with Andre the Giant. If you don't know who Andre the Giant is, then you haven't seen The Princess Bride. Okay, we've got five John Cena's and Andre the Giant. Who's going to win? And maybe not necessarily who's going to win, but my question is, are they going to cancel one another out? Thank you, private message. They're not going to cancel one another out because now all of a sudden our John Cena's, they might cancel one another out, but with Andre the Giant pulling as well, we're going to offset anything that they're canceling out. So when we have that lone pair of electrons, that's when we have a molecule that's not symmetrical, and we would say, well, that is a polar molecule. Okay. So I got a private message that was, how do we identify covalent or ionic compounds? Okay. So when it comes to identifying something as polar, nonpolar, a perfectly, what's important to think about here is the definitions. A perfectly covalent molecule, and I'm really sorry, I didn't lose track of time, but I just wanted to explain everything. And I said that I wasn't going to be talking about the exam grading at the very end, but that's where I am. I apologize sincerely. That wasn't on my intention. Um, Whenever we're classifying something as a covalent or an ionic compound or an ionic bond, um, a perfectly covalent bond is where two atoms have equal um, electronegativities. So there is a range. So if the electronegativity is, let's see if I can find, yeah, here we go. The electronegativity differences. I will give you those values if I ask you a question about this. So if we say the electronegativity difference is less than 5, well, that would be a nonpolar covalent bond. If it is from zero point 0.5 to 2.0, that is a polar covalent bond. Anything greater than that is still considered think about that as like the extreme end. It's so polar that it's covalent. Okay. Now, um, that's where I wanted to go with that. Now the last thing that I wanted to talk about, and I'm just going to kind of scribble this out, is the exam grading. Okay, so that covers most of the stuff that I need to cover for this upcoming exam. If you have questions, I've got office hours starting at 12:30. You can join the Zoom. I will be sending out an announcement regarding taking the exam. The I will be in my Zoom during the exam. If you have trouble with Proctorio, join that Zoom. We can talk about it. We can sort it out. Um, but here's the way that the exams work. Exam one, exam two. Exam one, you will have 3 attempts at it. Exam two, you'll basically have 3 attempts at it. These are labeled. That's absolutely fine. I'm recording this, so I'll post this on our Canvas page a little bit later. If you got to go, go. Um, so our exam one, your first attempt, we already took that. Our second attempt at exam number one is going to be your exam two score. And then your third attempt is the final. Exam two, your first attempt is exam two. Second, exam three. And then third is your final. Now, let's say on exam one, you got a, let's say on exam one, you got a 65. On exam two, let's say you get an 85. And then on the final, let's say you get an 87. 15% of your grade, I think, I can't remember the exact numbers right off the top of my head. 15% of your grade is going to be exam one. And so what I'm going to do is I'm going to look at these three scores, and the lowest two are going to be dropped. Now for exam number two, that's also, I believe, 15% of your grade. Don't quote me here, quote the syllabus. And on exam two, you got an 85. Exam three, you got a 91. And then the final, again, you get an 87. Well, this gets dropped, this gets dropped. And then on the final, well, the final, you don't have any sort of retakes on the final. You get an 87 on the final, you get an 87 on the final. And I believe that also accounts for 15% of your grade. If you'd like to talk about this after this upcoming exam, I'm all ears. I'd love to. If you want to talk about this and go into like, let's throw some exact numbers. I'm still a little bit confused. I've got office hours today, and I've got office hours on Wednesday. If you want to meet for office hours tomorrow, send me an email and we can set up a time. I apologize for going over. Um, like I said, I'll be posting this on our Canvas site a little bit later today. I hope you guys have a great day. Please don't hesitate to contact me if you've got questions about the exam, about the content on the exam. Deal? Okay. I have class at 12:30. What you addressed about covalent, nonpolar, and polar covalent, is that the same as? Yes. Yes. Okay, everyone. Have a great day. See y'all. I'm going to stop my share, stop my recording.